So here's our next example. It looks similar. This time the negative infinity is in the lower limit. And I just want to run through this log procedure again, just to see it again. So what we're going to do is we're going to split this out as a limit as a approaches negative infinity of the integral from a to 0 of this same thing, 2 over x squared minus 4x plus 3 dx. Yeah, once again, if the denominator didn't factor, you could consider completing the square here. I think since the denominator does factor, it's easier to do partial fractions, so because that factors pretty easily. Oh, by the way, another thing that we should consider is this. When I do this factoring of the denominator, this is also telling me where the vertical asymptotes are. The vertical asymptotes are at +3 and +1. Those are the vertical asymptotes of the integrand. So I should be sure that my vertical asymptotes 3 and 1 are not in the interval of integration. So 1 and 3 are both greater than 0, so they're not in this interval. If they were, if we ended up with vertical asymptotes that were inside this integral, then we'd have to break it up some more. And that would make it an even more obnoxious problem. All right, so we're going to just do our partial fraction decomposition now that we know that the vertical asymptotes are in fact not, I shouldn't talk and write at the same time, are not part of the integral. So we get 2 equals a times x minus 3 plus b times x minus 1. So we get 2 equals ax minus 3a plus bx minus b. There's no x's over here, so we have 0 equals a plus b. And then we have 2 equals negative 3a minus b. A lot of people like substitution so much, but look, come on. Eliminate negative 2a. So a equals negative 1, and then right away b equals 1. So now we know that our integral is the limit as a approaches negative infinity of the integral from a to 0 of negative 1 over x minus 1 plus 1 over x minus 3 dx. So that I can say that we'll do our antiderivative limit as a approaches negative infinity. So both my denominators have a derivative of 1, so I can just throw them in a log right away. Don't forget, though, that, for example, if this was 2x, I would have to put a 1/2 out here. This time I need the absolute value because my values here are all negative infinity to 0. All these values are negative. So I need the absolute value. I won't need it for long, but I will need it for right now. ln absolute value x minus 3. And that's evaluated from a to 0. So yeah, I got to pull this log trick again because this is going to be a negative infinity. Was it going negative infinity? Yeah, so the absolute value will go to positive infinity. So this will go to negative infinity. This will go to positive infinity. I can't really tell where it's going to go as a result unless I rewrite this as a fraction. Ln of, since the x minus 1 is the negative, it's going to go in the denominator. So this is x minus 3 over x minus 1. Yeah, from a to 0. So then this equals the limit as a approaches negative infinity of, let's put this, yeah, okay, so let's go ahead and go, when I put in the upper limit, I'm going to have 0. So why did I do that right away? Well, I already wrote this, so let's keep with it. So I put in the 0, and I'm going to get ln of the absolute value of negative 3 over negative 1. All right, so that turns out to be just ln of 3 anyway, right? And then that's what I get when I plug in the 0. Now I'm going to plug in the a and have ln of absolute value of a minus 3 over a minus 1. So I probably could have done this in one step, but I forgot what I was doing. So this is ln of 3, and then I'm going to have minus the limit as a approaches negative infinity of ln of absolute value of a minus 3 over a minus 1. So that equals ln of 3. Let's see if we can do this limit a little bit more intuitively this time. So as a approaches negative infinity, this rational expression has a horizontal asymptote at a equals 1. So whether we go to positive infinity or negative infinity, this inside this expression is going to 1. Absolute value of 1 is 1. Ln of 1 is 0. So it's minus 0. So my area is ln of 3. Done. Yeah? Nice. Okay, what's next? I want to do just 2 more examples. So I'm not going to do them necessarily on this video, but I'll just set it up, give you a chance to look at it, see if you can get it. Integral from 0 to 4 of e to the negative square root x over square root x dx. This is a good review of your integrating techniques as well. What technique are you going to use to do this integral?